Hello everyone, and welcome to your video for Honors Algebra 2 on absolute values and how to solve their equations and inequalities. The first thing you'll notice is on the screen right now your agenda for Tuesday, so you'll be able to see what the homework is. So after you get done watching this video, if you would like to get started on that, you most certainly could. You will have all day in class on Tuesday to keep working on this assignment if you so choose. All right, let's do a little review on what absolute value actually is here. Absolute value is the distance from 0 on a number line. So if you're looking to find the distance between a -3 and a 5, I'm willing to bet most of you right now can figure out what that distance is. If you were to graph those 2 points, you would know that they are 8 spots away from one another. But there's a few different ways that you could mathematically find 8 as your answer. You could take a -3 minus what that 5 is, take the absolute value of that, you get -8 inside of that absolute value, and you know that absolute value is a distance. A distance always has to be positive, so you would wind up with 8 as your final answer, a way to match what we found on our number line. The other way is kind of similar to that. It would be starting with that 5 minus the -3, absolute value of that. Well, the two negatives make a positive, so either way that you decide to notate that, you wind up with 8. You wind up with, in the first case, a -8 in your absolute value and then +8 in your absolute value. That's going to be a really important piece of information as we start to solve, first of all, equations with absolute value. So right now, you have an absolute value of 2x plus an 11 is equal to a 17. So first of all, this number that you have after the equal sign has to be positive. For that to be positive, well, we know that if it was negative, it wouldn't work. You wouldn't be able to solve and find and take the absolute value of something and have equal something negative. But when you do take the absolute value of something, you wind up with two things. So essentially, if we take here the absolute value to both sides, what that means is there can be two possibilities. So once we get those two possibilities, we technically know, just like we got a -8 and an 8 up here inside the absolute value, we could take a 2x plus an 11, and it should equal regular 17. And also, we could take a 2x plus an 11 that is equal to a -17. Both of these are going to give us values that we could plug back into this absolute value and actually have it be something that works for our x value. So if we do go through and solve this, we subtract 11 from both sides from the first, we get a 2x that's equal to a 6, or we end up with an x equals a 3 as one of our answers. As we're continuing to go through here, we can solve the left-hand side. And if we subtract 11 from both sides here, we now end up with a 2x that's equal to a -28, or an x that is equal to a -14. So what I want you to do right now is I want you to pause the video, plug both of these values back into the original equation, and you should find that both of them match. Both of them would work. You would have two big smiley faces as you were checking this particular problem over. All right, let's move on to the next couple here. So our goal is to get something in our equation that looks identical to what we started with here, where we just had an absolute value and then something after the equal sign. So in order for us to get, well, just an absolute value and an equal sign and then a number, we have a little bit of work to do. So the first thing that we can do is we can try to move certain terms to the same side of the equation. So let's start by adding a 1 to both sides. We can combine some like terms. We end up with a 2, and we have an absolute value of a 2x plus 1 equals a -5, and an absolute value of a 2x plus 1, and then plus a 7 at the very end of that equation. So what you may recognize now is that the two parts that are inside of our absolute value are the exact same. You have a 2x plus 1 there, and a 2x plus 1 that's inside of the absolute value. So we can actually take that and add it to both sides of our equation. It's just like saying we were adding a 5x to both sides of the equation. So when we do that, the -5 and the +5 of the absolute value cancel, and all we have is a 7 with our absolute value. 2x plus 1 is now equal to a regular 7. So you can see, hopefully now, that we're starting to get closer to that form that we wanted from the last problem that we did. Because now from here, we can divide both sides by a 7, and we end up with just that absolute value of a 2x plus 1 is equal to just a regular 1. And we can go and break this up into our positive and negative from this spot. We know that we have a 2x plus 1 that has to equal a negative 1, and a 2x plus 1 that has to equal just a positive 1. As we go through and solve, from the very top equation, we would end up with an x equals a 0. From the very bottom of the equation, we would end up with an x that's equal to a negative 1 as we go all the way through this. Again, what you're going to want to do here is check your answers to make sure when you do check, both of these work out as well. Okay, now here's your little hint as you're going through. We talked right at the very beginning of this video about when you had a number after the absolute value sign that was a negative. This is a big red flag right here. See the red flag? That is a huge spot that we need to try to identify, because you're trying to think about what number can you plug into this absolute value that's going to get you a negative number. There's none of them. You don't even have to do any work from this particular spot, because you hopefully know right away this is a no solution. You can try to solve this and you're going to get no answer as you go all the way through because of that negative sign that you had after your equal sign. 2 more problems for you here with your equations, just to show you a couple different forms that can come up. So as we're looking at number 4 here, you already have your absolute value, nothing on the same side of the absolute value, and you just have a regular number. So if we take the absolute value of both sides, we end up with one version of exactly what you saw there, and another version is going to be equal to your negative 32. So as we're solving both of these, we can take 7 away from the left. We end up with an x squared that's equal to a 25. And as you're square rooting both sides, I think you guys are starting to catch on to this a little bit more. Hopefully you recognize that this has 2 solutions. So we have an x equal a positive and negative 5 from that spot. If we try to do the same thing with the next equation that we have, we end up with an x squared that's equal to a negative 39. If we square root that, again, red flag shows up because we can't take the square root of a negative number. This is not going to work. This particular spot would be a no solution. So the only 2 answers that we have are our positive and negative 5. What I want you to do now is stop the video. I want you to write down number 5, and I want you to try to solve this. When you come back, I will have the answers for you on both of these spots. All right, so hopefully you went through, you solved both of these, and recognized that you could take the positive and the negative form of the absolute value, and when you solve here, you get your x squared is equal to a 10, and you got your x squared was equal to a 4. For final answers, you got a positive and a negative 2 all the way through, and since you can't break 10 down with the factor tree, you have a positive and negative square root of 10. So this particular problem has 4 different answers. So this is going to conclude the equations part of the notes. Now we move on to the inequality part of your notes. This is going to kind of continue with what we ended last week with. When you're looking at absolute value, you have an absolute value of x that is less than 3. So if you're thinking about all the numbers that work for this, you could plug in a 2, and that would work. You could plug in a 1. You could plug in a 0, and those might be the first numbers that you actually think of that would work. But there's also the negatives of each of these because we know absolute value is positive. So all of those numbers would work. Another way we could write this would be a negative 3 is less than x, which is less than 3. So it's all the numbers between negative 3 and 3, and notice how those are not included. What the form that you're going to see is going to deal a lot with is that x has to be greater than negative 3, and so it's all values that are bigger than negative 3, but also all the values that are less than 3. So if you come across here this particular sign to start, your less than sign, know that you're actually looking at 2 different parts that will be combined together. Okay. Now, if we kind of look at the opposite side of that spectrum, now you get the absolute value of x that has to be bigger than 3. So now you're thinking, okay, what numbers work? I'm sure you're probably thinking right away that 4, 5, 6, 7, you could keep going all the way through. Or how you could write that would be x has to be bigger than 3 with 3 not included. Hopefully you're starting to think of the other side of the spectrum too, some of these negative numbers. Because negative 4 would work. Negative 5 would work. Negative 6 would work. Negative 7 would work. All of these negative numbers would still work. So what we now have is a situation that is also x is less than a negative 3. So the situation that we would come up with now, this isn't an and situation because here there's no overlap in any of our intervals that we just had, where in this particular case, there was overlap between those two. Was the part that they had in common. So this is an or situation. So our final answer for this particular side would be our x is greater than a 3 or x is less than a negative 3. So you might think, well, how does this apply with any of the inequalities that we're trying to solve? If you have a less than in your equation, what that means, it means it's an and equation. So what your process to solve this is going to be, it's going to be whatever your c value is, whatever that number after your sign is, has to be less than x, and it has to be less than your c value. And on the other side of things, for the greater than, again, you started with a greater than sign in your basic equation, you're going to have an or problem. So you are going to have the same format where you're going to have x is greater than c, or you're going to have your x is less than a negative c. Follow the same form that we did on the top there. Now, I have 4 examples for you here. Okay. With the first example, again, look at what your sign is. Your sign starts out as a less than. And if it's a less than, then we know that it has to be an and question. So if it's an and question, how we're gonna set this up is we're gonna put our 3 minus x inside of our less thans, and we're gonna have the positive c value and the negative c value. So we have this 3 minus x, I'm just going to write this a little bit neater here. We have a 3 minus x that's on the inside, and then on the outside we have the positive 2 and the negative 2. So this is going to look identical to the types of compound inequalities that you solved to finish last week. So what you do to one part of the inequality, you have to do to all. So I'm going to subtract 3 from all parts of this inequality. I have a negative 5, that is less than a negative x, that is less than a negative 1. To get this x truly all by itself, I need to divide everything by a negative 1. Now I have a 5. I divide it by a negative, so the sign has to switch. I have an x, and then I have a 1 all the way through. So now if we read this, this says 5 is bigger than x, but then x is bigger than 1. So our final answer for this part is all of the values between 1 and 5. And notice how there is no equal to, so that means we have parentheses. Okay, we found all the values that would make this inequality true. Now, if we're solving for the next one, hopefully you notice that now we have the opposite sign. We have a greater than, which means we have an or question on our hands. So we're going to split this up into 2 inequalities. We have an x minus 3 that is greater than a 5, or we can have an x minus 3 that is less than a negative 5. So we're trying to solve both of these inequalities, 2 separate parts that are going to end up maybe being a union with our final answer. So we add 3 to both sides of the inequality. X greater than 8. To finish this out, or to get the other part of our answer, we add 3 to this, and now you get an x that is less than a negative 2. So if we're trying to write this in interval notation, we have all the numbers that are bigger than 8 to start. So parentheses, because there's no equal to. So all the numbers bigger than 8 is 8, and then our infinity or our infinity sign. And you keep going and know that we have our x that is less than a negative 2. So all numbers smaller than negative 2 would give us our negative infinity sign all the way until that negative 2. And we have a parenthesis with that all the way around as well. So notice there are your two basic examples of a less than or an and question, or a greater than and an or question. So now what we can make it a little more difficult is if we throw more stuff at you with these inequalities. Your goal is to get the format to be the exact same as we just did for those two problems. So the first thing we want to do is we're going to try to get this absolute value all by itself. So the first thing we want to do is subtract 2 in this third example. 5, absolute value of x minus 1 is less than or equal to 5. We divide both parts, both sides, by a 5, and now we get the absolute value of x minus 1 is less than or equal to a 1. And now again, it's less than or equal to, so it's an and question. So that means we have to put this absolute value inside. So we have x minus 1 is less than, and in this case, or equal to a 1. And then on the other side, that negative 1 is less than or equal to at x minus 1. Add 1 to both sides of your inequality. You end up with a 0 that is less than or equal to an x, which is less than or equal to a 2. So it's all of the values of x that are between these two answers, or if that's the case, we have brackets for this problem, 0, 2, and the brackets are around both of those pieces. Okay. Now, last but most certainly not least, you have a fraction question. So you have this divided by 3 in your problem. Notice that even though there's division that is inside of your absolute value, the absolute value is still all by itself, 100% by itself. So you can read it right now as an OR problem. If it's an OR problem, break it up into two pieces. X plus 5 over 3 is greater than or equal to your 7. And you have your 2x plus 5 divided by 3 is less than or equal to a negative 7. So we're just solving for both pieces here. No matter which one you're solving for first, you need to multiply both parts by 3. So you end up with a 2x plus 5 that is greater than or equal to 21. I take 5 away from both sides, end up with this 2x that is greater than or equal to 16. I divide, I end up with my x that is greater than or equal to an 8. So that's going to be one part of my final answer, but I still have this or. I still need to do my other version with the negative sign. So I multiply both sides by 3, end up with a 2x plus 5 that is less than or equal to a negative 21. Now again, I subtract 5 from both sides. I end up with a 2x that is less than or equal to a negative 26. Now I divide both parts by 2, and I'm looking at all the numbers that are less than or equal to a negative 13. So if I'm writing this final answer down from start to finish, it's all the numbers that are bigger than 8 and all the numbers that are less than a negative 13. So I have to start with a negative infinity until I reach that 13, but know that I have brackets now around this. I have my union as part of my answer because we're looking at all the numbers, including 8, that are bigger all the way up until my infinity. And I have what my final answer would be. So now you've learned enough information to adequately solve absolute values with equations and absolute values with inequalities. I look forward to answering any questions you have Tuesday in class. If you need to get started on the practice, here is your practice for the second part. Okay? It is also what you can look at here, your page 161. Technically what you can do is 1 through 73 every other odds. This is just that back half of the assignment. Hope you guys have a great rest of your night. I will see you on Tuesday.